Hey guys, welcome back to another video. My name's Larry. Today we're going to be doing a little bit of a OpenRocket tutorial, making some TARC rockets, so let's get right into it. So the first thing you want to do is get OpenRocket open, something like this, and so once you have OpenRocket open, take a look around. This is the software that we're going to be using to design the rocket. Up here on the top right corner, you can see we have like a bunch of different components. Well, right now only 3 are available, but the rest will become available as we add more parts to the rocket. On the top left right here, we have basically a design tree, which is like a list of parts of the rocket ordered here. And at the bottom is where you'll see the actual rocket as you add more parts to it. So we should start by adding a body tube. So the first thing you want to do is check the rules book for the TARC challenge and see if there's any restriction on the body tube diameter or the length. It's going to be in section 2.3. And so some things that you have to consider are that the rocket has to hold an egg, so the body tube has to be at least wide enough to hold the foam egg protector or whatever mechanism you're using to protect that egg. And so for this year's competition, I'd suggest going to maybe a BT70 or a BT80, which are 2 pretty standard rocket body tube sizes. So what we're going to do is go to apogeecomponents.com, which is basically a pretty reliable rocket part buying shop. We're going to click shop up here on the gray bar over here, go down to building supplies, and go to body tubes. So we got to find either a BT70 or a BT80. That's going to be in this section, 56 to 98 millimeters. And so scroll through here, find one to work with. We're going to use these slotted body tubes right here, BT70. And so what we're going to be right. So what we're going to be doing is we're going to basically make this rocket tube in OpenRocket. So I like to drag it over to the side. Then we have the stuff that we can just easily see. So body tube length, let's not worry about it. Let's see diameter first. So you can see here that the outer diameter and the inner diameter are on the Apogee website information. So what we're going to do is we're going to fill that out right here. So this is going to be 56.3 millimeters for my tube, and this one's going to be 5.54 centimeters. I don't know why this one's in millimeters, but I guess that's what it is. It should automatically figure out the wall thickness, I think that's right. And the body tube length is something that we can change depending on the rocket, because as long as it's less than this length, then it should be fine because we can cut it to whatever length we need. So we're just going to keep it at that, and then we can change it later, but just make sure it's under 45 centimeters later when we're designing. Something good to do is to just take the model number, copy it over, and put it in the comment section up on the top, because when we're buying the parts, this will help us remember where to get it. This component name is we'll call it capsule tube, because this is going to be the front part of the rocket that comes off. Here's what the capsule tube is. Close that. Alright, next step, we're going to get a nose cone on the rocket. So what you want to do is add a nose cone. So select this body tube right here, and then at the top you can see that all of these components have now lit up. So click nose cone, and let's close this for now. Because we did the body tube first, the nose cone appears on the right. So here we can just full screen this. Here at the top left corner, we can drag the nose cone above the capsule tube. Can we? Yeah, I think we can. There we go. So now it's like the nose cone is the front of the rocket. So I guess what you want to do is just go back to Apogee and just find a nose cone that fits this body tube. So as you can see, this is a BT70 right here. So we just go back to building supplies. And you click on nose cones. We're probably gonna be one of these. And then yeah, as you can see, this is a BT70 nose cone. I'm just gonna go with this foam one right here. And so what we can do is bring this to the side again, and just like last time, we're going to fill out all of these things. So this one is an elliptical nose cone. You can tell it because it's like sort of an oval shape over here. So we're gonna change this to ellipsoid, and then you can just dial in all of these lengths. So I'm gonna do that really quick. So you'll notice here, up here in this tab, there's a shoulder tab, and the shoulder is basically the part of the nose cone that extends into the body tube. And here on apogee, you can see there's a shoulder length. It's a 1 inch long shoulder. So we're gonna put 2.54 right here in the shoulder length section, and the diameter should just be the inside diameter of the tube. So I don't remember what that was. It's 5.54. So go back to the nose cone, shoulder, 5.54. And as always, we just go to the comment tab and put in the model number. Just again, so later when we're looking for the part, it'll be easy to find. Control V. And there you go. So let's continue with the next step, which is... Okay.
Sorry, I didn't get that.
Whoa. What we want to do next is we want to click on here, click on the component mass. Let's override this mass because it doesn't seem correct. Right now it's saying it's 0.355 grams, but here on apogee we know that it's 23.5 grams. So we override the mass to 23.5 grams. Enter that. And yeah, that's important because it'll affect our stability values. Right now it's not great because we only have 2 parts, but as we add more parts, it'll get better. So the next step I think we should add is a coupler tube. And what a coupler tube is basically the middle part of the tube that connects the 2 body tubes. So we have a fin can and we have a capsule portion of the rocket, and they're connected by a coupler tube. So we click coupler tube and we put that in the middle there. So again, we have to go to building supplies here in apogee, search for body tube couplers, and find the BT71 that fits our rocket. So I'm just going to speed that up right here. Alright, so now I have the coupler inside of this rocket. So if you go to, I don't know, 3D finished, you can see that we have the tube right here. It's the outer tube, the body, the capsule tube, and the coupler tube just sits right inside, and it should be glued onto this, and the nose cone's in the front. So back to our side view. Going down the rocket, the next thing we should add is another body tube for the fin can, which is the second part of the rocket. So that's going to be exactly the same as the capsule tube actually. So I think what we can do is we can just Control C, Control V, and there we have another one. And you'll notice that it comes with another coupler tube, but we don't need that, so we can delete that. I'm gonna make mine a little bit longer, maybe 30, and then that'll be my fin can for now. And all of the diameters here and here, and the commenting right here, it's all going to be the same because I just copied the part from earlier, because we're going to be using the exact same tube, just cut down to a different length. So next thing we're going to need to add is a bulkhead, because at the apogee of the rocket's flight, which is the tallest point of the flight, the ejection gases of the rocket are going to be pushing out the capsule tube, and if they're coming out here, then they're just going to go straight into whatever is up here, and we need a bulkhead right here so that the gases will come out here, push the bulkhead out, and then the 2 pieces will separate, ideally. So that's why we click the bulkhead here, and basically we'll just find a bulkhead on apogee and it'll fit right into the bottom of this coupler that we put in earlier. So let's go do that right now. So there we go. That's the basically the main structure of the front part of the rocket. So let's move on to the last few important parts. I guess we can just add centering rings, and centering rings are really important because they hold the motor of the rocket. So we need 2 of them. Basically, a centering ring is like a wooden circle that holds the inner tube in place, and the inner tube is where the motor is. So what we're going to do is go on Apogee and find 2 centering rings that will fit the motor that we are picking. I'm going to be using 29mm motors for this demonstration model. So I'm going to be using a 29mm to BT70 centering ring. So let's go design that right now. Alright, there we go. So now our centering rings are both in the back of the rocket here. So yeah, as you can see, in the 3D view, this is what they are. They're basically like little O-shaped circles and inside here we'll be putting an inner tube. So I guess we can click on here and then click inner tube, which is this one right here, and then we'll just fill in the 29mm inner tube that we said we were gonna have for the motor. So that goes in right there, and let's go back on Apogee and find the right inner tube. Alright, there we go. So now we have our inner tube, and basically the last main component we have is the fins. So let's click on the body tube and then click on fins. And so here what we can do is we can just play around with this. This is the one that gives you the most creative liberty to create any fin that works best for your designs. This will give you the most control over the flight of the rocket. So as you can see, changing the height, changing the angles and everything, that'll give wildly different stability values. But I suggest sort of just adding a random fin, closing it, and then once you add all the extra stuff that we're missing, then you can play around with the fins, and then once you get the stability value that you want, like right now here you can see it's 1.41, which is a little bit high, but we haven't added everything in yet, so it doesn't really matter. Once we add everything in, then you want a stability value of around, I don't know, 1.2 sounds like a good number to me. Anything between 1 and 1.5 is basically pretty reasonable. So once you add all the parts in that you need, here's a list of all the parts that we're going to need, and here's a list of all of their relative masses. Once all that stuff is added in, then we can just fine-tune the fins to what we want. So I'm going to go and add that right now. Alright, I'm back, and movie magic, as you can see, I have basically added everything else that you need for the rocket, except for one component, and that's the motor. So we go all the way up to this top tab where it says Motors and Configuration, and you'll have to click on which one is your motor mount. We said earlier that this inner tube down here is going to be our motor mount. So I clicked inner tube right here, and then you click on the configuration thing, you say new configuration, and then select the motor. So what motor you want is going to depend on how far it flies, but we're just going to click a random 29mm motor right now, just so that we can have something to figure out our fin situation with. So I'm going to click on this Cicerone one. It's reloadable one. It's one that we've used in the past. This F59 White Thunder. Click on it, and as you can see, my stability is now 1.05. It's been lowered because of the weight of the motor. So because it's now lower, I want to increase the size of the fin to increase the stability, because remember I want it around 1.2-ish. So as you can see, if I change the height to 6, that'll make it a little too high. So I'm just going to play around with this until it's something that I like and something that I'm comfortable making out of wood or on a 3D printer. Okay, that was easy. All I did was change the height by ½ centimeter, and now it is something that is more reasonable. And so there we go. There is the completed rocket. This rocket right here is basically has all the components that you need for a rocket. So if you go up to flight simulations, you can click on the simulation, just click plot. We don't really care about all the details right now. And that went to an apogee of 343 meters. How much is that? I don't know off the top of my head, so let's Google it. 343 meters to feet gives us 1125.33 feet, and that is a lot of feet. Our goal for this challenge is way more than that, so you're probably going to want to use a less powerful motor for the 2020 TARC challenge, but that's beside the point. So what we have is basically our first rocket. Start designing rockets of your own, and then fiddle with everything until it reaches the right height. For now, I guess that's all we have. Let me know if you have any questions. Make sure you attend the meetings Wednesday mornings, and yeah, like, comment, subscribe.